In previous video, we have done bromination of phenol as electrophilic substitution reaction. Bromination of phenol can be carried out in two types of solvents, polar and non-polar. In polar solvent, we were getting tri-substituted product, and in non-polar solvent, we were getting mono-substituted product. Reason already discussed in previous video, please check. Now we will start the mechanism of those reactions. Bromination of phenol mechanism. It is not involved in the syllabus of 12th class. It will be for JEE, NEET and B.Sc. Let's check the mechanism of those reactions. First, I will draw the mechanism of reaction with water as a solvent. Step 1. First, you need to understand water. This is water molecule. Oxygen is carrying two lone pairs and two sigma bonds it has made with hydrogen by the sharing of electrons. Oxygen is more electronegative than hydrogen, so these electrons are pulled toward oxygen. Now because this hydrogen is losing its electrons, so positive charge will come on it. And this hydrogen also positive charge, partial positive charge because electrons are slightly shifted toward oxygen, not completely. And because oxygen is getting two extra electrons, so partial negative charge will generate. Means this molecule have poles, positive, negative, positive, negative. We call them polar molecule. What are polar and non-polar molecules already discussed in 11th class, so I will not discuss them in detail here. Water molecule is polar. I will just say here that the polar molecules have a negative and positive fields around them. Obviously, positive field will be on hydrogen atom and a negative field will be on oxygen atom. Now what this water molecule is doing, check. We know we were adding bromine in phenol. This is bromine molecule. In bromine molecule, bromine atoms are there and between two atoms, single bond is there, sigma covalent bond, which is generated by the sharing of two electrons. One electron is of this bromine atom and one electron is of this bromine atom. Now both bromine atoms have a same electronegativity, so electrons will remain in center. Neither they will go to that side nor to that side. So what will be the charge? The charge on this bromine atom will be 0, on this bromine atom will be 0. Means overall charge of the molecule will be 0. So this molecule is non-polar. But when this bromine liquid is dissolved in water, we know water is a polar molecule. It have a positive and negative fields on it. Now what will happen? Suppose this bromine atom is coming in the contact of a positive field, means with the hydrogen atom. Due to this positive charge, these electrons, the bonded electrons, will move slightly toward this bromine atom. Due to which, the next condition of this bromine molecule will become this. Shared electrons will slightly move toward right-hand bromine. Here. So obviously, because out of these two electrons, one electron was of this bromine. So this right-hand bromine is getting extra electrons. So what charge will generate on it? Partial negative. And this bromine who has lost its electron, this electron was of this left-hand bromine and now this electron has gone toward right-hand bromine. So this bromine is losing control on its electrons. So what charge will develop? Positive charge. Means our non-polar bromine molecule will turns to polar molecule. This one. This water is doing with bromine. Water with its positive and negative field will make these central electrons toward one bromine atom, due to which the bromine molecule will become polar. Or you can understand this concept in different manner also. Here I have told you about the positive field. Suppose this right hand bromine is coming in the contact of negative field. So due to negative field, these electrons will feel repulsion and they will go away from the right-handed bromine. So these electrons will pass toward left-hand bromine. So now what will happen? These electrons will be close to left-hand bromine and away from right-hand bromine. So the positive charge will come on right-hand bromine and negative charge will come on left-hand bromine. In this fashion, also non-polar bromine will turn to polar. So this water is doing with bromine molecule. Now, what water is doing with phenol? As you know, phenol is also present in the reaction. This is our phenol. In phenol, between oxygen and hydrogen, there is a bond, and already electrons are toward oxygen side because oxygen is more electronegative. That's why it is getting partial negative charge, because it is getting one extra electron from hydrogen side. And because hydrogen is losing its electrons, so what charge? Positive. When this phenol will dissolve in water, and obviously in water two fields are there, negative I am writing here, positive I am writing here. So what water will do? Water will break this bond completely. With its negative field, it will attract its positive particle, and with its positive field, it will attract its negative particle like this. Due to which between oxygen and hydrogen bond will break and they will turn to ions. And obviously when oxygen and hydrogen bond will break, electrons will completely transfer toward oxygen because oxygen is more electronegative. So your oxygen will become completely negative particle, and this particle, this whole particle is known as phenoxide ion. And this H will release out as H positive. Means in water, phenol will turn to phenoxide ion. In previous video, I have discussed it with you that how water, in the presence of water, phenol was turning to phenoxide ion, due to which it is showing tri-substitution, because this benzene ring is highly activated by electrons donated by oxygen. That's why at one time 3 electrophiles can attack on these positions, 2 ortho and 1 para. So this is happening. This is a first step. Means if I write overall condition of this bromine and this phenol, when they will come in the contact of water, this bromine will turn to negative, positive, means slightly polarized bromine. It is now polar. Right now it is non-polar. And when phenol will come in the contact of H2O, it will turn to negatively charged oxygen. Please put lone pairs by yourself. Here also on bromine, 3 lone pairs will come. And what positive? Phenoxide ion. This is the first step of the mechanism. Now, second step. The role of water is over now. Let's start the reacting particles, what they are doing. This is phenoxide ion and this is polarized bromine molecule, this one. Now when this polarized bromine molecule will come near to this molecule, phenoxide ion, as you know, phenoxide ion is a high source of electron. So what will happen? These electrons which are already close to this bromine, right-handed bromine, they will completely shift toward bromine and bond will break. Like this. They were partially positive, partial negative due to water molecules. But when they will come in the contact of phenoxide ion, they will break completely their bond and one bromine will become brominium ion. This is brominium ion. And obviously it has lost its electron completely, so vacant orbital will generate on it. And with 3 lone pairs already there, so please draw them like this. And this bromine who got these electrons completely, already it was carrying 3 lone pairs. After bond breakage, it will carry 4 lone pairs. This is known as bromide ion. Why this has happened? Because when this molecule was going near to this molecule, as you know, this benzene ring, this oxygen have a high source of electron, are a high source of electron. So negative charge is there. Due to that negative charge, these electrons are feeling further repulsion and they are going more toward this right-handed side bromine. So bond will completely break, and this bromine, which were on a left-hand side, will become complete brominium ion. Now this brominium ion is an electrophile. This is electrophile. Electrophile looking for electron. Where we have electron? On a benzene ring. On what positions? Ortho and para position. Already many times we have discussed. Reasons very well known to us. So let's attack. First, let's attack it on ortho position like this. With its vacant orbital, it will try to make bond with this carbon. Now rest part you know what will happen. Okay, once I am, okay, let's be written it here. Vacant orbital. With its vacant orbital, it will try to make bond with this carbon. But for bond formation, 2 electrons are required. This bromine don't have electrons, so the responsibility will be of this carbon. How this carbon will provide electron? It will break bond from its neighboring carbon and will shift here like this. With the help of these 2 electrons, it will make dative bond with this brominium ion. Like this. So the vacant orbital of brominium ion will be filled. Now, because it is getting 1 electron, this electron is now toward bromine. So its positive charge will finish and 3 lone pairs as it is. But this carbon who has lost its electron will have a positive charge now, means vacant orbital, positive charge. And hydrogen is available there, so keep it as it is. Rest molecule, no change as it is. This one. This is the attack of electrophile on phenoxide ions benzene ring, and we are getting a carbocation there. This one. This is the second step. Now, please keep this bromide ion in your mind. I will neutralize it. This is the second step. Intermediate is generated, carbocation it is. Third step. As you know, the carbocations are unstable species. So obviously it will be destroyed. How? Like other mechanisms of electrophilic substitution reaction, same. This carbon has made this carbon as a carbocation. So this carbon will help it. How? By breaking bond from its hydrogen. Obviously when it will break bond from hydrogen, electrons it will get because it is more electronegative than hydrogen, and will shift these electrons here. Vacant orbital, 2 electrons, bond will be generated, and this hydrogen will be released out as H positive. Now why vacant orbital? Because it has lost its 1 electron. So vacant orbital will come with a positive charge. This we call hydronium ion. Now this hydronium ion will react with, in second step, bromide ion was generated with 4 pair of electron, this one. Vacant orbital and 1 lone pair, this bromide ion will use to make dative bond with this. Now because during dative bond formation, out of 2 electrons, 1 electron it will completely pass toward hydrogen here. So because hydrogen is getting 1 electron completely toward itself, so its positive charge will finish, and bromine is losing 1 electron completely toward hydrogen, so its negative charge will finish. Out of 2 electron, 1 electron it has transferred toward hydrogen, 1 it will keep with itself, rest 3 lone pairs on it. So HBr will generate. hydrobromic acid as a side product. And what about this molecule? Between them bond will generate, these two carbons here bond will generate, so pi bond will come. Rest molecule as it is, no change. In this fashion, first time substitution will happen. This is a first substitution. First hydrogen is substituted by first brominium ion, like this. Now, two more time with a similar pattern, substitution will happen. On which positions? Para and this ortho. How? Check. This is the whole mechanism we have. HBr will be as a side product. Now I am going to repeat it with this molecule. Second time substitution I am showing you. This molecule is generated. Now again, that polarized molecule of bromine will come near to this molecule. This right-handed we have made as a negative and this is positive. Now when it will go close to this molecule, you know this part is highly negative, electronegative, means negative charge is there, lot of electrons are there. On a benzene ring, pi electrons are there, on oxygen negative charge is there. So this high electronic field will repel these electrons and they will completely shift toward this bromine and bond will break like this. So this bromine will become brominium ion again, and this bromine will turns to bromide ion. Again the same pattern, this one. This brominium ion looking for electron, it have a vacant orbital, it's an electrophile. Now where it will attack? We know electrons are available on ortho and para position, but first ortho position is occupied by this bromine. So second option it have para, it will attack on para. Here we have hydrogen, same mechanism. When it will attack on this, these pi electrons will shift toward this carbon and these electrons it will use to make bond with this bromine. Here dative bond will generate, charge will finish, already discussed with you, hydrogen as it is. This carbon will become carbocation, rest molecule as it is, no change. This one. Now carbocation will be satisfied by this carbon who has made it. By breaking bond and shifting these electrons here, it will satisfy this. And this hydrogen will release out as H positive, which will react with this bromide ion to create another particle of HBr. And here, after bond formation between vacant orbital and these electrons, we will get this molecule. Bond will come here, bromine here adjusted, one bromine already here, this one. Now this is second time substitution had happened and this is second molecule of HBr which is generated here. Now similarly, third time substitution on this position and one more HBr will be eliminated out from the molecule. And why this 3 time substitution is happening? Because phenoxide is highly activating its benzene ring. In previous video we have discussed. So after all steps, if I write, this single phenoxide ion will completely reacts with how many bromine particles? Total 3 bromine particles in the presence of water. Out of these three bromine atom will be positive, these will be negative. These 3 brominium ion will join on ortho, 2 ortho positions and 1 para positions, one by one. Mechanism already discussed. Like this. And 3 hydrogens will be substituted, which will combine with these negatively charged bromine to create 3 particles of HBr. Now finally what will happen, this O negative will not remains like this. HBr are acidic in nature, you know they will deliver H positive ion definitely. So these H positive ions, some of these H positive ions will be absorbed by O negative, vacant orbital, extra lone pair on oxygen, dative bond will generate. Out of 2 electrons, 1 electron it will completely transfer toward oxygen, completely transfer toward hydrogen in dative bond, so its negative charge will finish. 1 electron it will keep with itself. Because hydrogen is getting extra electrons, so its positive charge will finish, both will become neutral. So this is the final molecule which was generated here as a white precipitate, which we call 2,4,6 tribromophenol. This was the mechanism when phenol reacts with bromine in the presence of water. And most important part is why tri-substitution is happening. Please check previous video. Now next mechanism with non-polar solvent like CS2 and CCl4. First step, listen very carefully. CS2 and CCl4, they are non-polar solvents. Only slight hint I will provide because this part is of 11th class. I hope you know it. First of all, like carbon disulfide, this is a bonding. Now sulfur is more electronegative than carbon slightly. So electrons are shift toward sulfur side because sulfur is getting 2 extra electron. These 2 electrons which are of carbon. So this sulfur should be -2. This sulfur should be -2. And this carbon, because it is losing 4 electrons of its, so it should be +4. So you will say positive and negative fields are there, so it should be polar. Then why you are calling it non-polar? It is non-polar due to its symmetry. Symmetrical molecules are non-polar instead of the fact they have a charges because the polarities are being cancelled out. It's a symmetrical, means linear molecule it is. 180-degree angle they have. So this pole is cancelling this pole. So overall polarity will be 0. Same here in CCl4. The carbon is making tetrahedral shape with these 4 chlorines. Chlorines are negatively charged because of higher electronegativity. 1 electron of carbon is transferring toward each chlorine. So negative charge. And this carbon will become +4. So you will say positive and negative charges are there. It must be polar molecule. No, it's also a symmetrical molecules. So in symmetrical molecule, the poles are cancelling each other. So overall polarity is 0. Means there is no negative or positive field here. Negative, positive fields are not present in these molecules. They are just working as a simple solvent. They are dissolving phenol and bromine liquid in them, and they are providing reaction medium for them. So there is no role of these solvents in the mechanism. Only what is happening directly, let me tell you. This is phenol. In first step, what is happening? And this is non-polar bromine molecule. Obviously, it will remains non-polar because solvent can't move these electrons like water was moving. So right now it will remains non-polar molecule. And phenol will remain phenol. It will not turn to phenoxide because non-polar solvent do not have this ability to break this bond like water was doing due to its attractive power. But non-polar solvent do not have that attractive power, so these bonds will not break and phenol will remain in this form. Phenoxide ion will not be generated. Now, what will happen? First step, When this non-polar molecule will go slight close to it, and obviously electrons are available, pi electrons are available, oxygen have a lone pair. So due to this, what will happen? These electrons will feel repulsion. The electrons which are already present on the benzene ring and on oxygen will repel these electrons, and they will slightly move toward one of the bromine side. Due to which between bromine and bromine bond will break, and obviously electrons will completely transfer toward this bromine, right-handed bromine, and this bromine will become brominium ion, and this bromine will become bromide ion, like in previous case. This mechanism is differ from previous mechanism only in the manner of solvent. There water was making this molecule as a polar, but here this non-polar molecule when will come in the contact of phenol, then it will become polar and bond will break. Brominium ion and brominide. After that, you know what will happen. This is an electrophile, same mechanism, looking for electrons, where it will get electrons on the benzene ring, and obviously which position, ortho or para. Suppose it is attacking on ortho position, so you know what will happen. These pi electrons will shift here. Directly I am writing the mechanism. You please write it by step. With the help of these electrons, it will make dative bond with brominium ion. The positive charge of brominium ion will finish, already discussed. It will be a dative bond, and this carbon will become carbocation because it has lost its electron. Now this electron has passed toward bromine, and OH as it is, no change. And here we have hydrogen, this hydrogen. Now this carbon will stabilize this carbocation. How? By breaking bond from its hydrogen and shifting these electrons here for the bond formation, due to which hydrogen will release out as H positive because it has lost its electron. This H positive will combine with Br negative to create HBr, and finally this molecule will turns to, between this carbon and this carbon bond will generate. Here now we don't have hydrogen, only Br will be there, rest molecule as it is, OH as it is, orthobromophenol. Similarly, with another molecule of phenol, you will attack on para position with another molecule of bromine. So para bromophenol will generate. Mechanism is same. And what is the difference? Here tri-substitution will not happen. Only one bromine you need to add on benzene ring, either on ortho position or on para position. So if I write the whole reaction, suppose we have two particles of phenol, so two molecules of bromine in CS2 or CCl4 as a solvent. One phenol will turns to orthobromophenol, and one I am turning to parabromophenol. Para will be major, ortho will be minor. Reason already discussed. Because two groups are very close, steric hindrance is there, instability will be there in the molecule. And here two groups are far away, no repulsion, no steric hindrance, the molecule is stable. That's why it is a major product. And obviously these positive bromines has joined with benzene, and these negative bromines will combine with H positive ions which were substituted from ortho and para position. So two particles of HBr will be eliminated out like this. That's it. This is the mechanism of the reaction. Please write this mechanism step by step properly with the proper heading of the steps. And in previous video we have discussed how the polarity of the solvent will decide tri-substitution or mono-substitution during reaction of phenol with bromine. Now in next video, we will understand sulfonation as a new electrophilic substitution reaction of phenol. That's it. Thank you very much for watching the video.